This tutorial explains how to perform conduction analysis using PEACE software. The model used for analysis is a square plate of dimension 1 meter by 1 meter with specified temperature boundary conditions. The temperature boundary condition is defined as 100 degrees Celsius along the left edge and 0 degrees Celsius along the right edge. The thermal conductivity along x and y directions are 17.4 watts per meter Kelvin. For creating geometry, first go to Geometry, Key Points, Create by XYZ. Next, give the coordinates of the points. First point 0, 0, 0, click Apply. Next point 1, 1, 0. Then click Apply. Now the points are created. Done message will be shown. We can label the points by clicking the label. Now surface can be created using Geometry, Surface, Create, Quad Surface. Click to snap to point, then select the corner points. First pick the first point. Next, drag and click the second point. Now the surface is created. We can shade to see the surface and rotate to see the shade view of the surface. Now click to front view and off the shading. We can label the surface and see the surface 1. Next, go to Mesh, FE Mesh, Quad. In the parameter box, select the surface 1. Give an initial value. Next, select the method to map. We can adjust the subdivisions by clicking the edges. After setting the correct subdivisions, we can click Apply. Now the mesh is ready. Now we can erase the surface. Now set the analysis type. Here we are going to do the conduction analysis, so set the analysis type to heat transfer steady state. Next, set the analysis options to multi-frontal. Click Apply. Now set the load and boundary conditions. Heat transfer boundary condition, nodal temperature, add. In the parameter box, select the nodes to be selected. In the node IDs, select the right boundary nodes and set the temperature as 0 degrees Celsius and click Apply. In the Edit menu, we can see the applied portions we have done. Next, add again the heat transfer temperature. Select the left edge boundary nodes. And in the temperature parameter box, type 100 and click Apply. Now the temperature boundary conditions are set. Now go to Material Properties. For that, Property, Material, Thermal, Add. In the element IDs, select all the element IDs. Then in the material data, give the conductivity values. Here the conductivity along x direction and y direction is 17.4. After setting the conductivity values, click OK. Now the material property is done. Now save the file to a proper directory. After saving, click Run Solver. After successfully finishing, finished successfully message will be shown on the message box. Now we can see the temperature distribution. For that, pause, contour, temperature distribution, click Apply. We can switch off the load and boundary conditions and see the temperature distribution. By clicking on the contour, we can see the temperature at each node. Now we can go to Pause, Path Plot. We can select a nodal path and click Apply. We can see the temperature distribution along the nodal path. We can click on the graph and see the values. In settings, we can change the distance and the temperature values.